Hello everyone, and welcome to this inaugural lecture. Usually, we would have been together on campus for this event, but of course, these are no ordinary times. The threat of the coronavirus pandemic is keeping us apart, but only in the physical sense of the word. We have thankfully been able to innovate, so you're watching one of our first ever fully online inaugural lectures. But what is that? An inaugural lecture? Well, it's simply an opportunity for an academic recently appointed or promoted to full professor to share their research and insights with colleagues, students, and the public at large. I say simply, but don't think it's not important, quite the contrary. Inaugural lectures are one of the cornerstones of academic life. They provide a mechanism for openly sharing knowledge, which has been at the heart of the academic project since the formation of the first university more than 1,000 years ago. To quote our own Professor Samuel James Shand, a lecturer in geology when Stellenbosch University was founded over 100 years ago, a university is not a lecture theatre or a library or a laboratory. It is not a building or a place at all. Its essence is a frame of mind. The true character of a university is the will to knowledge. So that's where this event fits in. It is part of the open exchange of ideas on the big stage of the Universitas Magistrorum et Scholarium, the community of teachers and scholars that is academia. Now, you might well ask, what does this mean in this age of the democratization of knowledge? Do professors really still matter when anyone with a smartphone and an internet connection can access the sum total of human knowledge? Yes, they do. In their book, The Innovative University, Clayton Christensen and Henry Eyring argue that universities can lay claim to an indispensable role because professors can play an invaluable role in helping students gain their footing in the flood of information that might otherwise overwhelm them. That is because scholarly communities have the collective insight and experience to answer a student's most vital questions, such as, what sources of information can I trust? What new information matters? What principles don't change? En as jy hierdie soort vraag op die hart het, is daar geen aanhef as beste professor nie. Jy kan op hulle kennis en insig, ervaring en wysheid staatmaak. Daarom hou ons die amp van professor in stand en gee ons graag die geleentheid aan elk van ons professore om 'n intreerede te hou. So, baie welkom en geniet die res van die program.
Good afternoon. My name is Ingrid Willard and I'm the Dean of the Faculty of Economic and Management Sciences here at Stellenbosch University. And it's my enormous privilege to welcome all of you here this afternoon. We welcome friends, family, academic members of staff, and members of the broader university community to the celebration of the promotion of Professor Hannelie to the rank of full professor in the Department of Logistics. An inaugural lecture is an opportunity for us to celebrate together with the new professor, but it's also an opportunity for the professor to profess. The word profess means publicly declare one's knowledge. And so we ask all new professors to go through this important rite of passage whereby they give a talk which is accessible to friends, family, and those from outside of their own academic community. So today we're celebrating together with Professor Hannelie, and it's my privilege to begin by giving you a short biographical sketch of Hannelie's career. Hannelie holds a DSc in Statistics and Operations Research, and she began her career at the Vaal Triangle campus of what was then Potchefstroom University and is today Northwest University. After several years there as both a junior lecturer and a lecturer, she moved on to a position in computer science at the University of the North, today the University of Limpopo. Having served there for almost a decade, she moved on to a career in statistical consultation. And while doing that, she also completed an MBA here at Stellenbosch University in 2002. She achieved the MBA cum laude. Since 2004, she's been a member of the Department of Logistics here at Stellenbosch University and has had an illustrious career with us, where she's taught across a wide range of domains, including operations research, quantitative management and forecasting, and has supervised large numbers of postgraduate students. Importantly, she was the chair of the Department of Logistics from 2011 to 2017. She's played a leading and collaborative role in a wide variety of research studies in human nutrition, anthropometrics, social demographics, and transport-related studies. She's the author and co-author of more than 60 accredited publications, an incredible achievement. And when I looked up on Google Scholar yesterday, I was amazed to discover that her work has been cited more than 4,500 times, a testament to the real impact that her work has had. Today, Professor Nell will be speaking to us on the topic of bringing dietary data closer to the truth with statistical adjustment, the 2018 Provincial Dietary Intake Survey as an example. So Professor Nell chose an example which I think to talk to us today about a study which is something which is accessible to all of us. It deals with the idea that when we ask people to give us information about what precisely they ate yesterday, there's going to be some variation in that none of us eats exactly the same thing each day of the week. So in this study, she grapples with how we can use statistical methods to adjust for the fact that there is within-person and between-person variation in nutritional intake. So I congratulate Professor Nell on a good choice of topic, something that I think we'll all find incredibly interesting. And I congratulate you again, Hannelie, on this fantastic promotion to full professor in the Department of Logistics. Thank you.
Thank you for this opportunity. It is an honor to present this address. This is a fun example of my latest research on the application of statistical techniques in the field of dietary intake studies. Just a short summary of what we are going to do or what we're going to look at. This address will look at the variation in dietary intake and discuss a method to adjust for variation and also for extreme intakes in dietary and the diet. Okay. We will go through the whole normal process when we is to do the background, do the methodology, then look at the application of this technique and also report results and a short conclusion. Diet is among the most important influences on human health. It is important to monitor food intake, especially for a population. Governments make decisions on food schemes for schools and so on, and also decisions on fortification of foods. And this is all based on results of dietary intake studies in populations. Usual intake is defined as the long-term average daily intake of a nutrient of food. Usual intakes can also be used to assess inadequate intakes of populations or groups within a population. And it is critical to the study of relationships between diet and biological parameters, or between diet and chronic diseases. The closer the dietary intake estimates are to the truth, the better the diet-disease relationships. The food we eat varies from person to person. We call it between-person variation. And it also varies from day to day for the same person. And we call that within-person variation. Within-person variation occurs due to the daily fluctuation of your diet or to seasonality. Between-person variation increases according to the heterogeneity of a population and the usual food patterns of different groups in a population. Ideally, for usual intake, the within-person variation should be very small. If not, more diet records are needed to capture the variation. The ratio of the within-person intake to between-person intakes will dictate the number of the diet records needed to obtain a correct intake evaluation. In the 70s and 80s, the golden standard for usual dietary intake assessment was a 7-day weighted food record. This requires the respondent or an enumerator to weigh all the beverages and foods at the time of consumption and record the weight and a detailed description of the food, including the preparation method and the brand names. Any waste on the plate must also be weighed and recorded. Imagine an enumerator walk with you the whole day and measure and look at what you eat and weigh it. Respondent fatigue resulted in changes in the diet, or items were left out to reduce the burden of recording the intakes, and this resulted in underestimating of the intake. And this method is obviously and definitely not suitable to study large populations. Because of the problems experienced with the 7-day weighted food record, methods such as a 24-hour recall and the food frequency questionnaire are used to investigate diet intakes of large groups. We are not going to look at food frequencies any further, but a single 24-hour recall has been the most frequently used because of its ease of administration and the short time over which the respondent has to recall food intake. The 7-day weighted food record of a subsample is often used to validate the 24-hour recall, and biomarkers are also used to validate dietary intakes. Biomarkers are variables measured in body fluids, like urine and blood samples, for example, that independently reflect the intake of the food. Example of urinary nitrogen, which they collect for 8 days a week, is necessary to estimate protein, potassium and sodium intake, and blood samples can be used to validate vitamin C and vitamin E intake. These are just examples. It's very expensive and logistically difficult to administer and to collect and process these biomarkers. Therefore, let us look at the single 24-hour recall. We know it might not be representative of a person's usual diet. One intake may not include seasonal or weekly variations in intake, and a single 24-hour administered in a sufficiently large population sample can adequately measure the mean intakes of that population, but it fails to depict correct the fraction of the population with usual intakes in the tails of the distribution due to the presence of the within-person variation. A further concept that is necessary to explain is an estimated average requirement. The estimated average requirement is the daily intake value of a nutrient that is estimated to meet the nutrient requirement of half of healthy individuals in a life stage and gender group. Previously, it's something similar to an RDA value, but the EAR is used to measure the prevalence of adequate intake in populations. The EAR fixed cut point approach plots the EAR value onto a distribution of a usual nutrient intake to establish a cut point, and then calculates the percentage of intakes that fall below that cut point. An intake below the EAR cut point is then deemed to reflect the risk of deficiency in the group, and this is also referred to as inadequate intake. An example what we have here is a graph of a single day 24-hour recall intake of a specific nutrient, whatever that is, and also the usual intake for that same nutrient. The green line represents the single day 24-hour recall, and the red line represents the distribution of the usual intake. Cut point A represents a requirement for nutrient adequacy, or EAR, and the area to the left of cut point A represents inadequacy. That's the percentage below the EAR. And cut point B represents the upper safe limit of that intake, and it reflects the risk. The means, notice that the means of the usual intake and the means of this 24-hour recall is the same, but the problem lies with the percentage below the cut points. The single day intake misleadingly shows a greater proportion of the population below the cut point, or a greater population at risk of inadequacy, as if when you compare it to the usual intake. Now, we are going to look at a method to help us to establish usual intakes. This is called the Nci method, that was developed by the National Cancer Institute of the United States Department of Health and Human Services, and it is used to calculate usual intakes from a single 24-hour recall and a small subsample of 2 or more 24-hour recalls. There are different models available with the Nci method. We are only going to look at the mount only, or the one-part model, which is designed for nutrients or foods that are consumed nearly every day by nearly everyone. And the requirements of this model is that at least a subset of individuals must have 2 or more additional 24-hour recalls, and that subset doesn't need to be large, as we will see later. Another requirement is that less than 5% of the individuals in the group must have 0 values or 0 intakes for that nutrient. The steps in the Nci method are as follows. The first step is to input the day 1, 2, and 3. We use 3 days of dietary intake, or 24-hour recall intakes. But remember, day 2 and day 3 is only a small subsample. And we do preliminary data adjustments. That means if there are 0 values, we replace the 0 values with half between the 0 and the minimum intake for that specific nutrient. The second step is to transform the intakes to normality. And the observed nutrients has usually the distributions of these nutrient intakes is very skewed and definitely not normal. It's very rare that you find a normal distribution. So the distributions need to be transformed to normality using a Box-Cox power transformation. And still, in part of the step then is to estimate the usual intake model parameters. We take the assumption now that the nutrient intakes have a normal distribution. We work with the transformed values, and we obtain estimates for the components of the within and the between individual variances from the transformed intake. It actually means that we fit a nonlinear mixed model, and we fit that for different strata, and we use different age groups for the strata. This formula shows the nonlinear mixed model, where on the left-hand side represents the transformed dietary intake values, the RIJs. The lambda value is calculated in the process, and this is an indication of how close the transformed values will be to normal. On the right-hand side, we have 2 different sets of covariates. The first set, the XKIs, represent between person variables, and the second set of covariates, the ZLIJs, represent the variable that models the within person variation. And this is typically an indicator variable that identifies with the number of repeated intake. So it's either a 1 or a 2 or a 3. The betas are the coefficients of the between person and within person covariates. The error terms can also be partitioned to represent the between person errors and the within person errors. The next step, after we have modeled the intakes, we estimate the usual intake distribution of the population. The parameters that we have calculated in step 2 are now used to simulate an appropriate population. We simulated about 100 observations per person. And then we back transform the simulated values to the original scale. These values represent the usual intake distribution of the simulated population. We calculate then the estimated percentage of the population whose usual intakes fall below a cutoff or an EIR value, and we also calculate the percentiles for that distribution. Sampling weights are used in the process, but we also calculated balanced replicate. We use the balanced repeated replicate method to estimate the standard errors of the statistics that represent the usual intakes. The software is available on this website. Let us look at the application of this method. The Provincial Dietary Intake Study was launched in Gauteng and the Western Cape in 2018. And these two provinces were selected as they are the two most economically active and rapidly urbanizing provinces in South Africa. The sampling strategy incorporates a multi-stage stratified cluster random sampling design, and enumerator areas were selected at the first stage, and systematic sampling of the household took place within each EA at the second stage. The selected child was also chosen randomly if there was more than one child in the age group 1 to 9 years in the household. A total of 84 EAs were selected from 6 strata. The strata were the two provinces, and then urban formal, urban informal, and rural areas within each province. A total of 733 children were surveyed in Gauteng and 593 children in the Western Cape. Sample weights were also calculated to ensure that the results are representative of the population. This is just a screenshot of an EA, one of the EAs that was chosen for the survey. And these pictures were printed on A3 paper and given to the enumerators so that it helped them to identify a path through an EA or an area, and it helps them to select households at random. A set of questionnaires were completed at each selected household. One of them was the 24-hour recall. A technique called the multiple pass 24-hour recall was applied to administer this questionnaire. The first step of this method, or we call it the quick list, is to just ask the respondent, give me a quick summary of the foods that you ate in the past 24 hours. In the second step, the forgotten foods, the interviewer reviews the data collected and probes for food that might have been forgotten. Usually they forget snacks and things or cold drinks that they had in between. In the third pass, the meal time and the eating location is collected. During the fourth pass, detailed descriptions and portion sizes are collected, and the time interval between meals is reviewed to again check for additional foods. The clarification is also obtained regarding the portion sizes, and they used models of dishes and measures and geometric shapes and food labels to identify the portion sizes. And in the final pass is the last opportunity to remember more food items. This is an example of a typical 24-hour recall that was completed. On the left is the summary of the sheet. So what we can see here is that they give a quick list of the food items. This is the first step. In the second step, they ask for forgotten foods, and this is listed in this column. In the third step, they transfer these food items to the main questionnaire, but they also give timestamps and places where the foods might have been eaten and when. So it is in specific time slots of the day. In the fourth step, the details are completed. For example, if they say they had porridge, they can say, oh, it was maltabella and it was brown porridge. If they had milk, then they say it is long life milk, and so forth. They also give detailed description of the portions, but it's descriptive according to the food models and so on. So they give shallow bowl or a teaspoon or moderate milk in the coffee or whatever. The last, after this has been completed, the supervisors then code the 24-hour forms, and this is the last two columns. They allocate specific weight values to these descriptive portion sizes, and they also code the food items or allocate specific food codes to each item. The food codes were then entered into the 27 food composition tables, and this helps us to convert the intake of food to specific nutrient intakes. And this is just an example of what it looks like for bread. If you take bread, this is the nutrients that are in bread and the quantities per 100 gram. The full sample of 1326 children of 1 to 9 year olds completed the 24-hour recall, and 2 additional 24-hour recalls were completed for a subsample of 148 children in the second recall, and 146 children completed the third recall. For logistic reasons, these subsamples were recruited from the last 5 EAs that were visited in each province. And the same houses were visited, and the same children were interviewed again. But they were visited 1 week apart, so that it is an independent recall from the previous one. If we can get back to the mathematics again and our covariates, which are so important, when analyzing the data and designing this model, the covariates that were selected for the between person includes the province, the area of residence, whether it's formal, urban, informal, urban, or rural, the gender of the child, and whether the day was a usual day. The covariates that were selected for within person includes that indicator variable into the model to indicate that the second and third recalls are being modeled. That helps us to allow for between person variation. Just a note again on the error terms. The main purpose of this model is to estimate how much of the variation in the reported intake is within person or day-to-day variation, because that is usually what is the cause of the wide variation in the data. And this can then be eliminated from the simulation of the usual intakes. When we look at the results, I actually wanted to start off just by talking about the food items and what nutrients do they represent, or the other way around. If we look at calcium intake, in this study, milk and porridge and pilchards and sardines and Mars and breast milk substitutes and margarine, and yogurt are good, were of the main contributors to the calcium intake in these children. For vitamin A, it was mostly organ meat and porridge and vitamin A-rich vegetables. For vitamin C, it was mainly fruit juice, potatoes, and vitamin C vegetables. Vitamin D was mostly canned pilchards and sardines and eggs and medium-fat margarine. Vitamin B12 was mainly organ meat and pilchards and milk and beef. And folate mainly maize porridge, I was surprised, and brown bread and white bread. The reason for this is that maize porridge and white bread and brown bread were fortified since 2003, and folate was one of the fortificants in that mix. And niacin is also maize porridge, chicken, bread, fiber, a high fiber cereal, and thiamine maize porridge, bread cereal. We can see that the fortified food items contributed largely to the high vitamin intake of these nutrients. When we look at the main thing, which is the between person and within person variation in the model, we notice that there are high variations, especially for vitamin A in the younger children and even in the 3 to 5 years. The very high ratio for vitamin D in the age 3 to 5 years, niacin on the young children, and then vitamin B12 in the children aged 3 to 5 years. These high ratios is an indication of the high within-person variation in the intake of those nutrients. The reason why it might be so high for vitamin A and also maybe for vitamin B12 and vitamin D as well might be the fact that the intake is mainly dependent on items such as organ meat and sardines, and children don't eat that every day. So you will find quite a high weekly variation in the intake of these items. An item that, let me see if there's another one that doesn't vary so much. A folate, it's not a large that 3.6 is still high, but a folate is more dependent on maize porridge, bread, white bread, brown bread, and maybe some occasional vegetables. And if it's like that, these ratios wouldn't be so, because it's items that people eat usually every day. When we look at the shape of the distribution for calcium, we notice, in this case, the red line is the distribution of the usual intake, whereas the blue line is the distribution of the day 1 intake, or the single 24-hour recall. Notice how skewed the original distribution is, and after we have applied the method, the distribution of the usual intake is more normal, although it's still not perfectly normal. The lambda value that we use from the Box-Cox transformation gives us an indication of normality. If the lambda value is close to 0, the original distribution was extremely skewed. And if lambda is close to 0.5, it means that the transformation, or that the distribution, becomes closer to normal. In the case of calcium, we'll see calcium and vitamin D are two special cases. The EIR values are greater than the mean or the median values. And you'll see the EIR for calcium is 500 for this children in this age group, age 1 to 2 years. And you can see that EIR value is greater than the mean and the median. The percentage below the EIR that reflects inadequacy is quite high. And in this case, what is going to happen is that for usual intakes, that percentage of inadequate intake will actually be higher under the usual intake distribution than for the original distribution. Also notice when we plot the cumulative distribution of the intakes that the spread of the usual intake is narrower than the spread of the original intake. The Nci method managed to get rid of the largest part of the tail of that distribution. We can also see that here, in this slide, we look at the percentage below the EIR, but we also notice that the mean values are approximately the same. I think the mean here is 4 to 4.5, and that one is 4 to 3.3. So the mean values are quite close, but the median values differ. And for day 1 intake, it's 339, and for the median for the usual intake is 378. So it's what we said in the beginning. The usual intakes or the mean values of usual intakes and the single 24-hour recall are usually the same, but once you look at percentiles or median intakes or percentage below cut points, the results of those are not the same. Vitamin A is an example of a distribution that's extremely skewed. And you can think of what are the contributors to vitamin A: organ meats, sardines, and those things which are not eaten daily, but occasionally. And what we see here is a classic example of what happens is that the red line here is the 24-hour recall intake. It's extremely skewed with a large tail. And the usual intake, the blue line, it managed to bring it closer to normality, but never perfect normal. If we, it's better illustrated on the cumulative distribution graph, where you look at the distribution of the usual intake. It's the blue line. You can see it starts further at about maybe 250. It ranges to about 1,000, whereas the original distribution of the 24-hour recall starts here way below at about 90 up to about 1,000 something. So you can see that the usual intakes, the tails of the distribution has been cut. If you look at the percentage of intake below the EIR, we notice that for the 24-hour recall, the percentage below the EIR is 16%, whereas it's only 1% below the EIR for the usual intake. And this blue line reflects that, and also this line here will show you that quite a small percentage is below the EIR for the usual intakes. This shows us that when you interpret using a single 24-hour recall and you want to interpret the prevalence of inadequate intake, you might overestimate the inadequacy. And here we can see the mean and median values. The mean values are still close to each other, or still close, very same, but the median values and the percentiles will differ largely. Then in our results, I've divided it into two groups, calcium and vitamin D, because they are so inadequate. Even with usual intakes, the inadequacy is even more than with the single 24-hour recall. And we can see that for calcium, when we look at usual intake, in the age group 1 to 2 years, 70% of the children reflected inadequate intake. For the 3 to 5 years, 94% of children. And for the 6 to 9 years, 99% of the children. And even with vitamin D we have a bit of a problem. that you never know how much sun or exposure to sun the people get to say that they have definitely a shortage of vitamin D. But vitamin D is also quite in the news lately because of its ability to fight, what do you call that, inflammation. Right. If we look at these two nutrients, I think they should really be further investigated. For example, milk, pilchards, yogurt, eggs are the main contributor in this population to these two nutrients, and maybe people should be advised to increase their intakes of those nutrients. If we further just look quickly at vitamin A, B12 and folate, these are distributions that are quite skewed, also because of the organ meats and the pilchards and that contribute to these intakes. And what we see here with vitamin A, the percentage below intake is just 1% with usual intake, whereas 16% if we use a single 24-hour recall. Note the big difference between the usual intake, the percentage inadequacy, 0.4% versus 24% in the 3 to 5 year group, and 12% versus 29% in the 6 to 9 year group. Vitamin B12 is 14% versus 34%, and 0 versus 36%, and 5 versus 35%. And the same with folate, the large differences between the actual intake of a single 24-hour recall and if you use the usual intakes. This again alerts us to when you want to measure inadequacy, you might overmeasure the adequacy of certain nutrients intakes. These graphs just show the percentage of inadequate intakes for the different, this is for the calcium and iron and zinc, some minerals that we have here. You can see the inadequacy, the day one and the usual intake. For both of them, it's quite large. For iron, it's quite similar, the usual intake and the day one intake, because the distribution of iron was originally not too far from normal, and the same for zinc. If we look at the vitamins A, D, E, and C, we notice the difference in vitamin A, and we notice there's a slight difference in vitamin E and even in vitamin C between the day one intake and the usual intakes, the percentage of or the prevalence of inadequacy. And then we have the B vitamins, where thiamine looks similar, niacin, there's a slight difference. Riboflavin, the difference is greater than 10% between the estimates. And with vitamin B12, it's also greater than 10%, and also with folate. I never knew that folate is a B vitamin. Right, in summary, vitamin A, B12, and folate have lambda values less than 0.15, meaning that those distributions are quite skewed, and that the intakes of those 24-hour recalls, actually, if you don't use this Nci method, you need to increase the number of 24-hour recalls, more recalls, to correctly reflect the intake of those nutrient values. Calcium and vitamin D have the EAR value is greater than the median value and the mean values, and what we will find is that the inadequacy is actually greater for usual intakes than what is reflected in a single 24-hour recall. Vitamin A, E, C, B12, riboflavin, and folate, there's a large difference between the inadequate intake as calculated by the usual intakes than when we use the single 24-hour recall. And with iron, zinc, thiamine, niacin, and vitamin B6, it's quite similar between the two. This brings us to the conclusion that the prevalence of dietary insufficiency could be overestimated if intakes derived from a single 24-hour recall are not adjusted. The Nci method allows for the estimation of population exposure without conducting repeated 24-hour recalls on the whole sample. And the study shows actually that a small subsample is sufficient. Our subsample was 11%. It also demonstrates the importance of using usual intakes to estimate the prevalence of risk of low dietary intake, as these estimates are used in major decisions regarding public health. We have had already a number of publications on this research since we launched the project in October 2018. There are 3 publications, and I would just like to thank a few people here. First of all, to my creator for my health, the ability to work, to do research, and to enjoy a privileged life. I'm grateful to my children, my son-in-law, Erin, Dane, and Hannelie, for their constant love, support, and their encouragement. I'm extremely proud and grateful to my family. It includes Joe, Skyke, Boot, Flip, Tinus, Anne, Sharon, and Babes, and their families. And thank you for your love over the years. I thank the staff of the Department of Logistics for being caring and sharing the vision of growing people through research and training, and to the management team of the US and the Faculty of Economic and Management Sciences. I'm grateful for the support I received, especially during my term as chair of this department. And finally, I would like to thank Nelia Stein and Marianne Senekal, who are not only good friends, but valued collaborators on this research project. I also acknowledge funding for this project from the International Life Science Institute of South Africa and their industry partners, and the NRF Foundation, and for UCT. And I also declare no conflict of interest for this project. I thank you so much.
I would like to start out with congratulating Hannelie on her inaugural lecture. In her case, I think it is truly deserved and a great honor for me to speak on her behalf and to thank people for this event. Hannelie is really, in my mind, a valuable academic in the department. Her long-standing reputation of delivering good research over a long time is a testimony to the way in which she conducts herself as an academic. And I think she's an example for the younger staff. She's an example to live up to, of how you can create a constant stream of good research and publish it in good and high-ranking journals. So thank you, Hannelie, for contributing and building the reputation of the department in this way. As a person, I also want to thank Hannelie for her contribution in the department. She's really a hard-working colleague. She worked towards the greater good in the department. She's almost a kind of a motherly figure in the department, and I think helped the younger staff to really build themselves up and to work towards improving themselves. Hannelie, so thank you for your contribution as an academic, and also thank you for your contribution as an individual and as a person in the department. I really appreciate it. I would also like to thank the rector and the dean for their words of introduction and welcoming for this event. Also thank you for the way in which you lead the university and the faculty in a way that you create an environment where academics like Hannelie can excel and become full professors. Thank you for creating such an environment for people to further their careers. I would also like to thank Ronel Beekers for organizing and making the arrangements for this day. It was especially challenging with adhering to all the COVID-19 rules and regulations. Thank you, Ronel, for organizing everything and getting everybody at the right times in and out of the building. I would also like to thank the staff from corporate communication and marketing for helping with the organization of this event, as well as filming everything. This surely wouldn't have been possible without your help. I would also like to thank Remy du Plessis, who is in the first place and here for his IT support, but also have to take up other duties like opening up the building for us and making sure that we are adhering to all the COVID-19 protocols. Thank you, Remy, for being always available when we need you and stepping up and doing a great job. Finally, I would like to thank the School of Accountancy for using their lecture hall for us to take this inaugural lecture. So I would like to end off to give the biggest possible and the warmest possible congratulations to Hannelie for achieving this huge goal in her life. I'm really proud of you, and I'm really valuing you as an academic and a colleague in the department. Thank you.